Hi there. This video is on Unit 7. I want to talk to you about three things. One is about KSP and how to calculate things using ice tables. Two is about Le Chatelier's principle, and I want to make sure you know how to write about it in the AP perspective. I'm not sure if Levinson taught you that part, so make sure to hit that. And part three is I just want to recap, like this should be on your note card about K's, and then this document's called Write This, Not That, to make sure that was hit with you this year. Okay, so let's give this a go. Okay, I got two different problems here. They're both related to each other. I'm going to start with the one on the left. KSP for CaF2 is that number at 25 degrees Celsius. I'm going to calculate the molar solubility. Whenever you're looking at KSP, what that really means is we're looking at calcium fluoride as a solid and how it dissolves in water to create its ions. So the first thing I'm going to do is write the KSP expression. KSP equals, I only include the aqueous and the gases, and not the solids. Calcium 2 plus, chlorine 1 minus, and that 2 up here goes as a 2. The power of 2. That's my KSP expression. One thing to be careful of is you always include these charges, the 2 plus and the 1 minus. If you don't, it looks like you've got solids in there and it's incorrect. So be very careful of that. So the next thing I'm going to do is I want to find the molar solubility, which means I want to find how much can actually dissolve. So my KSP they give me, 3.9 times 10 to the negative 11, is equal to, I'm going to call these values x and 2x. Now, you could really call them anything you want, but it's going to be a lot easier. Lots of times people call them x. I think that's what Levinson did. I like to use x because it's just algebra. So x and 2x. I know it's x and 2x because if I have like x amount of this actually dissolve, it'll create x and 2x amount. This is a 1 to 2 ratio, so I have to call this 2x, so I'm going to call this x. Now, some people might neglect to put this 2 in there, but remember, there's several 2's here, but they have different reasons. This 2 of the 2x is because, like I just said, x and 2x, it's a 1 to 2 ratio. This 2 right here is here because of the definition of KSP, because of how KSP is defined as. KSP says you have to put the 2 there. That's why the 2 is there. All right. In the end, I'm going to solve. I'm going to get x. 2.1 times 10 to the negative 4 molar. Got to put some units down there. So the molar solubility of that is 2.1 times 10 to the 4. There we go. Take a look at the other side. Calculate the molar solubility of CaF2 in a solution that is, here's got a common ion sort of thing. So I'm going to rewrite the equation. Okay, so what this problem is actually saying is, if I happen to have it in calcium nitrate, I can see a common ion right there with calcium. So that's like saying I'm going to add to this side of the equation. Well, according to Le Chatelier's principle, if it applies a stress on this side, the product side, it's going to shift to create more of the solid. Which means my molar solubility that I get should have less fluorine actually in solution. So I've got equilibrium, everything's beautiful. I add calcium. Now the calcium has to hook up with some fluorines to shift and remake some solid. Because some of these have now hooked up with calcium, we have less fluorine. And that's kind of what I'm trying to calculate. How much less do I have going on? Okay. Okay, so once again, I'm gonna call myself like an ice table here. That's probably what you did. Initially, well, first of all, I don't care about this column at all, because that's the solids, and that's not part of the KSP expression at all. Initially, I have x and 2x amount of these. But then I'm going to change it. I'm going to add an amount. I happen to add 0.01. I don't add any chlorine, though. So then in equilibrium, my E, I get x plus 0.01. And then this would be my 2x. All right. So now I'm going to put it in my KSP expression. And I get KSP 3.9 is equal to my calcium concentration, which is this x plus 0.01 times 2x squared. Now, you have your fancy calculators that can solve this quadratic equation no problem. However, if you don't want to solve a quadratic equation, you do have to show some work. The idea that this x right here, x is much smaller than 0.01. it is much smaller than 0.01, which is why I can neglect it. So that way we're going to assume that 0.01 plus x is really equal to just 0.01. Now in the AP world, do they want to see this assumption? Yeah, that's going to be something. They want to see that your brain kind of understands what's going on here. So I'm going to take out this x part. X with an x. There we go. Now I'm going to just solve for x here. So 3.9 times 10 to the negative 11 equals 0.01 times 4x squared. I'm going to solve this way to get x is 3.12 times 10 to the negative 5 molar. All right. So from there you can see that this 3.12 times 10 to the negative 5 molar and 2.1 times 10 to the negative 4 molar, I can see that this number right here is a smaller number, which does prove that as we add a common ion, it has a lower molar solubility. Less fluorine is actually going to be able to dissolve. Fluorine is actually 2x of this, so 2 times that, because it's connected with the calcium to create more calcium chloride ion, the calcium chloride solid. Okay. Next thing we're going to talk about is Le Chatelier's principle. According to Le Chatelier's principle, there are 3 things that happen when we change. Now, when you were filling out your survey, you didn't say you had any problems with Le Chat, which you might not. But I don't really know that you were taught like an AP answer for these things, so I don't make sure by talking about that here. Also, I'm going to talk about inert gases. I'm not sure she hit that either. All right. If I was going to make this one, I'm going to look at concentration first. Concentration, I'm going to calculate with a K, C for concentration. So I've got the concentration of H2. Now I know these are a gas and CO. So most of the time you're going to do it in a pressure, but I'm going to do it in concentration first and then hit it with the pressure. I'm not going to do my solid here because that doesn't matter. So I'm looking at Kc here. If I change the concentration, like, I don't know, let's say I'm going to add more of this CO. According to Le Chatelier's principle, if you add to this right side, it's going to shift to remake more of the reactants. But you can't answer the problem that way. If they said, what happens if you add more CO gas? You can't answer it the way I just answered. That's an honors answer. It's not an AP answer. An AP answer would be like this. Okay, I've just changed things. So I'm going to call this QC. So now I've got CO, which is now a bigger number, which has now created the idea that my Q is greater than my K. My Q is greater than my K because I added more CO, carbon monoxide. Because Q is greater than K, it must proceed to the reactants to reestablish equilibrium. That's an AP answer. Q is greater than K because I added CO. Therefore, it must proceed. That's the word they want to use, not shift. Shift doesn't work. You can't shift because it's not equilibrium. So Q is greater than K, which means it will proceed towards the reactants to remake equilibrium. That's an AP answer right there. Let's look at it in a different way. Let's look at pressure. So pressure, I'm going to use Kp. You gotta be very careful of that. They'll get you. If you don't use the little p's like I'm doing here, and you use actual concentrations, they're going to dock you off when they ask for Kp. So now I've got this problem. Let's say with the pressure, I don't know, what do I want to do? I want to, pressure and volume go together. So let's say I'll make it more stressful situation. I'm going to decrease the volume. So I'm going to decrease the volume. If I decrease the volume on a container, the pressure increases. Decreasing volume increases the pressure. Let's say I'm going to cut the volume by half. If you cut the volume by half, it's really going to increase the pressure by 2. So all of these pressures here are now going to go up by 2. So this is now going to be 2p of what it was before. I'm going to calculate my Q. This is now 2p of what it was before, and this is now 2p of what it was before. So my Q is actually my K, just kind of like 2 times each of them. You would think that in a way that the pressure, if it increased by 2, it really wouldn't change too, because the top and bottom is the same. But you can see the top and bottom are not the same. So if I suddenly did this math, these 2's will cancel, but this 2 right here is still there. So what that means is my Q and my K are not equal. My Q is actually 2 times my K. My K is the stuff in the green, and I just multiplied by 2, so my Q is greater than my K. If my Q is greater than my K, then again, it's going to proceed to the reactants to remake the equilibrium. So I'm hoping you're seeing the verbiage I'm using here. That's what they're looking for. Okay. The last thing I wanted to hit about this is about an inert gas. With an inert gas, let's say you got this system in equilibrium and you're looking at pressures and everything is hunky-dory. What I'm going to add is like neon or argon or krypton or any of the inert gases, which is usually the noble gases. If you add any inert gas, it does nothing to the equilibrium. So let's say I add neon. Well, where does neon even fit into this Q expression? It doesn't. So if the Ne or neon doesn't even go into the K or the Q's, then it can't affect equilibrium. So the answer is, what would happen if you add an inert gas? Nothing would happen. It doesn't affect equilibrium because it doesn't affect your K expression. Okay. Now what I want to do is show you. I wasn't here for unit 7, so make sure. What I would make sure you have on your note card also is these equations. It's so easy to forget. Like if you reverse, what happens to the K? If you double it, what happens to the K? The K gets squared. So this would be like just something I would definitely put on my note card, this idea. You guys didn't say you had any problem with it, so that's good. And then my write this, not that. It's not mine. I got it from somebody else. And it's going to be part of what I'm going to ask you guys to read later on next week, but I want to hit it here because it's Unit 7. Things that I talked about, remember to include charges. Don't want to mess that up. Remember that in Kp, you use the P, which is also what I talked about. When you do the K with the C, you want to use the concentrations. Make sure to have it as a bracket, not like as a parentheses, because parentheses mean nothing. Brackets, the little brackets, they mean something. They mean concentration. Make sure this K does not have any units. The little k of rate log K, that one has units, but this big K does not. A lot of times they're going to ask you about the K, which is greater than 1. That is something I want to talk about here. See how K is 1.210 to the third? Some might say that's a large number, therefore we'll have a lot of products. You don't want to say it that way. You want to say K is greater than 1, therefore we'll have a lot of products. K is greater than 1, therefore a lot of products. Use the words proceeds, not shift. And if you're wondering like why, this is like, you want to say proceeds, you don't want to say shift, and here's why you don't want to say shift if you're reading this chart. We did that one, use stoichiometry. Here's the idea of X, like assuming X is small so it can be ignored. I did it more in a notation. They did it with words. You want to do it in one way or the other. Discussion of Q versus K. So this is how I was discussing Le Chatelier's principle. You can't just say reduces stress. It doesn't show your real understanding. Okay, so those are the kind of things I want to hit. If you want any reasons for that, they've got this reference right here. And that's when you can look in these old documents, you can see in the green, like this is where they're proving, like you need to do what these things are. I'm going to have you look at the rest of this document later, but I know that I covered it in units 1 through 5 when I was actually teaching it, and unit 6 didn't have anything that was like, oh, that's drastic. I covered those in the video too. So you have kind of covered it all. I'm just going to have you review it. Okay, that's unit 7.